And now it's a quadratic that, A, we need to rewrite into proper form with the sine squared first, the sine second, and the constant third. I'm also going to divide everything by -1 to flip all the signs because I hate when my leading coefficient is negative. So that'll give me 2 sine squared x minus 3 sine x minus 2. And now it's just, what kind of problem? Factoring. Yep. Quadratic factoring. So we have no option other than 2 sine x times sine x. We have to use 2 and 1. The question is, do I do 2 and 1 or 1 and 2? Because this one's going to get doubled, and this one is not. So 1 and 2 or 2 and 1? 1 and 2, because we want that 4. Do we want that to be a positive 4 or a negative 4? Negative 4 plus 1 will give us negative 3. Perfect? So this one gives us sine x equals negative 1/2 when we tee it up. This one gives us sine x equals 2. Where should we go from here, Michelle? Okay, so what quadrants are we in? 3 and 4. And what's our reference angle? Nope. Make sure you learn your values by Friday. Stephanie, what's our reference angle? Pi over 6. So I'm going to label this 6 pi over 6, right? Sine of pi over 6 is 1/2. So the third quadrant angle is 7 pi over 6. And the fourth quadrant angle is 11 pi over 6. So there are 2 solutions. And then from here, Nathan, z. Correct. Because you can't take the inverse sine of anything greater than 1. So we have 2 solutions in our interval from 0 to 2 pi, and we're good. Number 8, again a mixture of cosines and sines. Thoughts here? Kendall? Yep. Double angle. Thanks for the help, Josh. Kendall, pick which double angle formula for cosine of 2x we should use, you think? You should have. That's your right-hand man. Get those sheets out. And why did you choose 1 minus 2 sine squared? Right, good. So we want the whole thing in terms of sine. So negative 2 sine squared x plus 3 sine x. And then your negative 2 with your positive 1 just makes minus 1. Again, I hate that negative, so I'm going to divide everything by negative 1. And factor. I don't really have any choices to make here. 2 sine x and sine x has to be, 1 and 1 has to be, they both have to have the same sign because it's a positive one, and the middle sign is a negative, so I need a double negative. So then we get sine x equals 1/2 or sine x equals 1. Haley, tell me what to do from here. Okay, which quadrant? Or quadrants? 1 and 2. What's my reference angle? So I'll label this 6 pi over 6. So what are my 2 answers? Yep. Okay, that's from the first equation. What do we do with the second equation, Jack? Good. He just knows that. So when you're dealing with 1, I always do for sine 0, 1, 0, -1. So it's just this pi over 2 angle. I don't know what you guys think of, but I think of that. Okay, any questions on that? 9 is we need creative people in the bunch. Liam. We did something similar to this when we were doing a proof. We multiplied by 2 over 2 a while ago to create 2 sine x cosine x. So similarly here, we want to create 2 sine x cosine x. So if I multiply both sides by 2, now this 2 sine x cosine x, I'm going to use my double angle formula backwards and make it the sine of 2x equals 1. Stephen? I probably could. Sine, there's not just one option. So sine times cosine. So he's thinking he wants to use that one. Can you do it that way for me? And then I'm going to grab yours in a second so we can see it. In the meantime, we're going to finish out this one. So with this one, we do have to deal with the adjusted period, right? The stretch or compression. So rather than finding an x right off the bat between 0 and 2 pi times 2 times 2 times 2, we're going to come up with all the 2x values that are between 0 and 4 pi. So there's only one, well, no, there's how many times between 0 and 4 pi? There's one full circle, a second full circle. How many times does the sine equal 1? Twice. Where at? 2x could equal pi over 2, or 2x could equal 2 pi over 4? Did you say 2 pi over 4? 2 pi over 4 is the same thing as pi over 2. So do it this way. Label this 2 pi over 2. So this is 4 pi over 2. So this is 5 pi over 2. Then when you divide both sides by 2, you're going to get x equals pi over 4 and x equals 5 pi over 4. And so your 2x answers are between 0 and 2 pi, as they should have been. Stephen, how's that going for you over there? Okay, I'm still going to come back to you. But he may be, I mean, it's an option what he's doing. I'm sure we could get it to work out. He's going to prove whether or not we can in a minute. Number 10, maybe Stephen's got your head in the appropriate place. I would say here, sine minus cosine, we should probably use, what do you think? Can we do a sum to product? Yeah, that's what I'm looking for, but we don't have a sine minus cosine on our reference sheet, so we got to be a little more creative than that. Sine minus cosine equals 1. I've got a crazy idea. I'm just not sure. Do you see sine minus cosine anywhere on here? I don't think so. We only have 4 and 4. But who's got a crazy idea? Let's get creative. Steven? We can do that. Right? Let's think about that. If 3 equals 1 plus 2, if we square both sides, should they still be equal? Yeah, okay. So it's going to keep it equal. All right, let's do that. That wasn't my crazy idea, but I like it. Sine squared x, then we'll get minus 2 sine x cosine x plus cosine squared x equals 1. You little devil, you. I like it. What can we do with this? Come on, Liz. Double angle here. What else? Well, I was just going to go with sine squared plus cosine squared equals 1. Right? But the same thing would happen. If you had subtracted your sine squared over, 1 minus sine squared could be replaced with cosine squared, and the cosine squared and the cosine squared would cancel. Similarly, I'm going to do sine squared plus cosine squared is 1, and the 1 and the 1 will cancel. So this part is minus sine of 2x, and then this is sine squared plus cosine squared is just plus 1 equals 1. And then those will cancel. So it'll be negative sine of 2x equals 0. The negative now does nothing, means nothing, so it's just the sine of 2x equals 0. And we have an adjusted period again. So times 2 times 2 times 2 tells us that 2x has to be between 0 and 4 pi. So how many times between 0 and 4 pi does sine equal 0? 4 times. Well, sort of. 3. Because we're not including 4 pi. That's all. So 2x could equal 0. 2x could equal pi. 2x could equal, oh no, you're right, 2 pi. And then 2x could equal 3 pi. Right? 4, not 5. And then you don't do 4 pi. So when you solve all of those, x equals 0, x equals pi over 2, x equals pi, x equals 3 pi over 2. Good stuff? My crazy idea, and I would have to play around to see if it works, was to maybe multiply by the conjugate on both sides. Sine x plus cosine x and sine, I don't know what would have happened. But it was my thought. Maybe I'll play around with it in a minute. This is calculator stuff, so get out your calculators. Just to remember that, you know, obviously we're putting in front of you all these ones that perfectly work out, but there's, you know, that's not always reality. It's going to be reality on your test because there's no calculator, but in the event that you do get your calculator thrown at you at any point in time, wink wink, if I'm solving for x, I just use inverse tangent. What mode should my calculator be in? Radians. The indication there is because they're telling us to let x be between 0 and 2 pi, so make sure your mode is in radians. And then inverse tangent. Now, here's the piece with this. When we do inverse tangent, our answer is going to be in one of two quadrants. What are our two quadrant options? Right. But when it gives us our x value, x is going to be between negative pi over 2 and pi over 2. Actually, with tangent, that has parentheses. Okay? Oops, sorry. That's the inverse tangent domain, or range rather. where we're going to get an x between those two numbers. If x happens to be between 0 and pi over 2, then we're also in the interval that the equation says we have to be. But if our x is in the interval from negative pi over 2 to 0, we need to kind of find its coterminal that's between 0 and 2 pi, right? Because this one's fourth quadrant version of an angle gives us a negative angle, whereas this one's fourth quadrant version is between 3 pi over 2 and 2 pi and is positive. So if and when that happens, we have to be careful of that. So this particular one gives us 1.4 decimal places. 1.4929. And is that between 0 and 2 pi, which is technically 0 and 6.28-ish? Yes, right? Good. When we do inverse cosine, what's our x going to be between? 0 and pi, quadrants 1 and 2. Now, no matter what we get then here for the inverse cosine, sorry, we're not done. Go back to A. I just thought of something. That's only the first quadrant angle. There's a second time between 0 and 2 pi if we're giving all the solutions in this interval. There's a second time when tangent is positive, right? Our calculator only gives us one of them. It gives us the first quadrant version because it was our calculator is limited to giving us an output in 1 or 4. So this is the reference angle. You with me? 1.4929. What other quadrant are we in? Yes. Which this is 3.14. And then how do I get the angle in that quadrant? Add what? Right, since this is our reference angle, we have to go this much past pi. So pi plus 1.4929, which is, and I want to do this on my calculator because I want to round it to the nearest, the fourth decimal place, 10th, 100,000, 10,000. 4.6344. That's where having a calculator can screw you up because you think, oh, did it on my calculator, got the answer, move on. But you have to think about all your solutions between 0 and 2 pi. Stephen? You would actually subtract it from pi to get in your second quadrant. We can do one like that. I'll do one like that. Just give me a minute. Cosine here. This is going to give us an answer in between 0 and pi. You guys should already know which quadrant's it going to be in. Quadrant 2. So the calculator is going to give us our quadrant 2 angle. So inverse cosine of negative 0.4317 should give us our quadrant 2 angle, which it does, right? That's just under 3.14. Okay? So x equals 2.0172. Now, this is tricky. Because here's pi. Here's our angle. 2.0172. What is our reference angle? Or how do you find it? Right, pi minus that. So if we do pi minus that answer, our reference angle is 1.1244. So what other quadrant should we be looking in between 0 and 2 pi where the cosine is negative? 3, which means we have to go this much past pi. Yes? You with me? So x has to equal pi plus that reference angle of 1.1244. So on my calculator, I'm going to do pi plus that angle, 4.2660. And those are my two solutions. Tricky? So your calculator is always going to give you one, but there's definitely going to be some legwork in the thought process of finding the other option. Good? And C is kind of or 12, I guess, is a sine example. Something that's not factorable. How do you solve it? Quadratic formula. So for the moment, I'm going to replace sine x with a y. So I'm going to do y squared minus y minus 1 equals 0. I'm going to do the quadratic formula here. Okay? So y equals, what's my negative b? What's the opposite of b? 1. Plus or minus the square root. What's b squared? What, minus 4 times a of 1 times c of negative 1. All over 2a is just 2 here. So this is 1 plus or minus the square root of 5 over 2. Minus 4ac. b squared minus 4ac. So I'm going to come up with this decimal. 1 plus the square root of 5 divided by 2 is 1.618, or 1 minus the square root of 5 divided by 2 is negative 0.618. Now, y is the same thing as sine x. I just kind of took it out to make it clearer. So the two equations we have to worry about solutions from are here. Which equation do we like better? Y, Connor. Right, your sine of any angle will never be greater than 1. So actually, I like this one better because I can just cross it out. I don't like the other one because I actually have to do work for it. Okay? So now, when I'm doing the inverse sine, it's going to give me an angle in either the first or fourth quadrant between negative pi over 2 and positive pi over 2. What quadrant do you know it's going to give you your answer in, first of all? The 4. We just have to figure out what that is, right? So if I do inverse sine, now I'm going to use that exact number, not the rounded version. So I'm going to grab that negative 0.618033 and find the inverse sine. And there's my fourth quadrant angle. But I can't use that as a solution. Why? I mean, I need to do more with it, but I can't use that verbatim as a solution. Why? Right, because we need our solutions between 0 and 2 pi with these, and that's not between 0 and 2 pi. That's less than 0. So I can though find its coterminal just by adding on what? Right, I can just add on 2 pi to that. Why did I do 618? I meant 6662. Negative 0.6662. But even that, I'm just writing that. I'm going to use this one for my calculator so as to not round. So add 2 pi onto that, and it will give me the coterminal 5.6169. So there's one solution. What other quadrant am I in if sine is negative? 3. So how do I find this angle? Not minus, because that's going to bring me back here. No, it's not. The reference angle is still 0.6662. Do we see that? The inverse sine angle that they gave me, because it always is between negative pi over 2 and positive pi over 2, was this negative thing. But the reference angle is 0.6662 still. So if I want the third quadrant version, I'm going to take pi, and I'm going to add on that amount, that 0.6662 reference angle. So pi plus, aren't you glad you don't have your calculators now? I'm going to have to just write that down. No, because you don't have a calculator. But it will come up somewhere. Don't you worry. But doesn't it make you glad you don't have a calculator? Because it makes things a little trickier. Right. Well, aren't you glad you don't have a calculator portion? Yeah. So that's tricky on all fronts, because when you're dealing with your calculator oftentimes, mainly with sines and tangents, gives you an answer that's out of the interval that the problem wants the answers in, which actually isn't the biggest deal for that particular answer, because you can just add on 2 pi to it to get it to be the coterminal version. But when it comes time to find the second angle in the second quadrant, where sine or tangent is also negative, can be a little tricky, because you got to think about the reference angle and whether you're going after pi or before pi by that reference angle. It's tricky. Again, a lot of intangible amounts of work there, mental thought processes that have to go on. So your homework is down here. Tricked you, I put it on the left. This day is really all about kind of using substitutions. How did that one go, Stephen? You didn't know what to do? It's a good thing we got some time. So going back to Stephen's idea, and you can just sit pretty. And he did not see the double angle multiply both sides by 2, so he uses product to sum. Yes? So this is the same thing, sine cosine, as 1/2 brackets. Sine of alpha plus beta is 2x plus sine of alpha minus beta, which is 0. Oh, that's great. Because sine of 0 is 0. And then it's just half sine of 2x equals 1/2. Divide away your coefficient, so you're going to get sine of 2x equals 1. You with me? So your interval, which is traditionally x having to be between 0 and 2 pi. Is this the same place we were on our notes anyway? Yeah. So doing it a different way, we still have the same equation to solve. I'm concerned with my second idea here on this one. I'm not as confident, and I'm thankful for Stephen right now because he had an idea that worked. But my thought was to multiply maybe by the conjugate, because that makes fun stuff happen.
Yeah.
So if I multiply both sides by sine x plus cosine x, yes please. Just keeps it warmer, thank you. So this is going to become the difference of perfect squares. Sine squared x minus cosine squared x equals sine x plus cosine x. Oh.
That is essentially nothing.
Wait a minute. Can I, what'd you say? Did someone think this was going to go someplace good? What if I make this 1 minus cosine squared x minus cosine squared x? So that'll be 1 minus 2 cosine squared x. This is just the double angle of cosine, isn't it? It is. Oh no, that's not the double angle of cosine. It's in the opposite order. Actually, but it's the same as the negative. When you negate both sides, negating a binomial flips the order of subtraction, right? Yes. Like if you do this, x minus 3, and you negate it, that just makes it 3 minus x. So we could use the negative cosine of 2 theta. I'm still stuck though because I want to get it all in terms of sines or cosines. I would have failed. I did this the other day. I wonder how I did it. I don't remember doing... Oh, I did square both sides. Huh. Just now, we know. Add that to your bag of tools. Multiplying by the conjugate's a good technique for proving sometimes, but it doesn't seem to be useful for solving. I could make this the negative cosine of 2x. Right, but the point is it comes down to squaring both sides. I can't get away from that. So why not just do that from the start? Right. Well, we learned that you aren't going to use multiplying by the conjugates much in solving. Yes, in proving. No in solving.